Hi everyone, my name is Mr. Anwar and today we're going to have a quick chat about numbers. Specifically, you guys know the numbers from 1 to 10, but we're going to look at two other types of number systems. And why? Well, because humans use the decimal number system, 1 to 10, but your phone, your tablet, and your computers use a different number system called binary. And then after we've looked at that, we're going to check out one more number system, hexadecimal. So let's see what we got. Okay everyone, we're going to talk about different number systems, but before we start, I'd like to see can you count the first 10 numbers? Go ahead and give it a go. Now if you said the first 10 numbers was 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, well, you're wrong. The first 10 numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is sometimes called the denary number system, or sometimes it's called the decimal number system. Denary or decimal, it is a base 10 number system because there are 10 numbers in it. A computer, however, is called base 2. Why is it called base 2? Because a computer uses binary, and binary only ever has two numbers, 0 and 1. Let's say we have a decimal number system. In this example, we have 25, and we want to convert it into binary. Well, let's see how that will look. Up here we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. It's always 2 to the power of because we want to convert into base 2. So let's go ahead and start converting 25 into binary. Well, 128 is bigger than 25, so we're going to put a 0 in there. 64 is bigger, a 0 in there. 32 is bigger, a 0 in there. 16 can fit, so we can have 16. We can have 8 as well. So 16 plus 8 is 24. If we add 4, we get 28, so we don't need that. If we add 2, we'll get 26, and we don't need that. But if we add 1, we'll get 25. 16 plus 8 plus 1. So our binary number, 25, becomes 0, 0, 0, 1, 1, 0, 0, 1. 16 plus 8 plus 1 is 25. Let's try another. Let's try the number 69 into binary. Again, 128 is too big, but 64 fits. So 64 plus 4 is 68, plus 1 is 69, and then everything else will be a 0. So, decimal 69 into binary, or decimal 69 into binary, 0, 1, 0, 0, 0, 1, 0, 1. 64 plus 4 plus 1 is 69. What if you wanted to convert a binary number into a decimal number? Well, let's have a look at this example. Here we have 1, 0, 0, 0, 1, 1, 1, 0. So we have 128 plus 8 plus 4 plus 2. And that equals 142. So binary 1000 1110 in decimal is 142. Let's try another one. Let's try this. 000 101 00 into base 10. Well, let's write it out. 000 101 00. Let's see what that makes. We have 16 plus 4 is 20. Binary is a base 2 number system. 0 and 1. Decimal is base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's another number system called hexadecimal. Hexadecimal is base 16. It uses 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So what are A, B, C, D, E, and F? Well, let's have a look. In binary, 0, 0, 0, 0 is the same as saying decimal 0, and in hex 0. In binary, 0001 is 1 in decimal and 1 in hex. 0010 is 2 in decimal, 2 in hex. 0011 is 3 and 3. 0100 is 4 and 4. 0101, 5 and 5. And we go all the way down and we come to my favorite. 1010 is 10 in decimal, but in hex we call it A. And the reason it's my favorite, because in binary it looks like 1010, which is 10 in decimal, and A in hex. 11, 1011, 11 in decimal, but in hex we write B. 1100, 12 in decimal, C in hex. 1101, 13 and D. 1110, 14, which is E. And finally, 1111 is 15, or F in hex. Now that we've seen that, let's do some conversion. We're going to convert the number 1D8 from hex into decimal. Now, if you remember in base 2, when we were converting in binary, we did 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. And we used 2 because binary is base 2. Hexadecimal is base 16. So we have 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3, 16 to the power of 4, 16 to the power of 5, 16 to the power of 6, and 16 to the power of 7. If you need more, just continue. So let's convert 1D8 from hex to decimal. We write it underneath, and we have 1D8, and this 1 is the same as saying 1 times 256. This D is the same as saying D times 16. And this 8 is the same as saying 8 times 1. So let's see the answers. Well, we know 1 times 256 is 256. 8 times 1 is 1. But what about D times 16? Well, if we have a look again, D is the same as saying 13. So we have 1 times 256, 13 times 16, 8 times 1, which is that? 256 plus 208 plus 8 equals 472. 1D8 in hex is the same as saying 472 in base 10. What about this one? 3ABC. First we'll write 3ABC, and then we have 3 times 4096, A times 256, B times 16, C times 1. That's the same as saying 3 times 4096. A is 10, so 10 times 256. B is the same as 11, 11 times 16. C is the same as 12, 12 times 1. Or 12,288 plus 2,560 plus 176 plus 12 equals 15,036. 3ABC in hex is the same as saying 15,036 in decimal. What if you want to convert a hexadecimal without a calculator? Well, let's try this. 5BA into decimal without a calculator. The method I'm going to show you now is super cool because 1, you don't need a calculator, and 2, you actually find out the binary number as well. So let's check it out. You got to remember that every hex digit is 4 binary bits long. So let's do this one together. We have 5BA, 5 in binary. Well, I don't need the 8, but I need the 4. I don't need the 2. I'll have the 1. 4 plus 1 is 5. So 0, 1, 0, 1 in 5. B is the same as saying 11. So we'll have 8, 9, 10, 11. So 11 in decimal, or B in hexadecimal, is 1011 in binary. And my favorite number, A, or 10, is the same as saying 1, 0, 1, 0. So 5BA in hex converted into binary is 0101 1011 1010. Once we have this number, we will just convert that binary number into decimal just like we did before. So we have 0101, 1011, 1010. And that's 1024, add 256, add 128, add 32, add 16, add 8, and add 2. All of that equals 1466. So 5BA in hex is 1466 in decimal, and 0101, 1011, 1010 in binary. All of what we've done so far is converting from hexadecimal. What if we want to convert to hexadecimal? Well, let's check this out. We're going to want the number 456, which is a decimal number, and we want to make that into a hex number. And what we do, we divide. 456 has 3 digits, so we just take the first 3 digits for hex. So 1, 2, 3 digits for hex. I don't need this. I don't need this. In fact, I don't need any of that. So let's start. We'll do 256 divided by 456. It fits one time, and we have a remainder of 200. Then we will take this number here, 16 to the power of 1, and we'll do 16 divided by our remainder of 200. It goes in 12 times, and it has a remainder of 8. Now we're going to take that remainder and divide it by this number, 1. So we have 1 divided by 8 is 8, and we have a remainder of 0. So far we have 1, 12, 8. Well, 1, 12, 8 is not a hex number because 12 is the same as saying C. So what we have is 1C8. So 456 in hex is the same as 1C8.